And welcome back to Mr. Gregoris Math. Today we're taking a look at finding a vertex of a quadratic by getting it into factored form. So let's say we're given a particular quadratic, like y equals x squared plus 7x plus 10. And we're asked, hey, let's find the roots and vertex of this quadratic. So part A might be put y in factored form. Now, we do this by factoring it as a trinomial. So we can see there's no common factor. We have 1, 7, and 10. There's no squares, so I shouldn't search for my special types. So I know I'm just going to go ahead and use my structure for factoring a simple trinomial. That's the setup. The signs, the first sign is positive, so the largest factor is positive. The second sign is positive, so the signs are the same. And I'm going to do a chart for 10. So my chart for 10 is my factor chart. I have 1 and 10, 2 and 5. And I can check very quickly and see that positive 5 plus 2 is 7. So my factors are 5 and 2. So that might be part A. Part B would then ask, find the roots or zeros of y. Now the zeros are the value of x that make y equal to 0. Otherwise known as the roots of the place where the quadratic goes through the x-axis. So to find the roots of the zeros, I'm looking for a number that if I put in place of x would make the whole thing equal to 0. And because if any one term that's multiplied together is 0, the whole thing is 0, I can consider these at a time. So I'm going to write it down as y equals x plus 5, x plus 2. And from x plus 5, I have x equals negative 5. That's a possible root because negative 5 plus 5 is 0, so this product would be 0. And then from x plus 2, I have x equals negative 2 is a root. So those are my two roots that I have for this particular quadratic. So if it asks you to find the roots or zeros, you go to factored form, and then you state the roots by flipping the sign. Now there's another little trick you have to do if there's a coefficient, but don't worry about that in the applied class. Part C, we need to maybe find the vertex, because that's another one of the features of a quadratic that we're looking for. Now, we can find the vertex a number of different ways. If we're already in factored form, though, we realize that halfway in between our roots of our quadratic, so here's negative 2, here's 5, this quadratic is going to have its vertex exactly halfway in between. So the distance between one root and the center line and the other root and the center line is where your vertex is, and that's divided by 2. So to find this, we can find our x value of our vertex by adding our two roots. We sometimes call them r and s for the first root and the second root, and dividing it by 2. So in this case, we'd have negative 5 plus negative 2 divided by 2, which is negative 3.5. Now that is the x value of the vertex. To then find the y value of the vertex, I just need to substitute negative 3.5 into my equation everywhere where I see an x. So this is going to simplify to positive 1.5 times negative 1.5, which is going to be negative 2.25. So that means my vertex is going to have the x-coordinate of negative 3.5 and the y-coordinate of negative 2.25. And so that's how we can take a question from standard form, factor it, find the roots, and use those roots to find the vertex. By the way, very often they ask, or it's asked as part D, find the y-intercept. And that's the last feature of a quadratic that we can find from a particular form. So find the y-intercept. This is where the quadratic crosses the y-axis. In this case, the quadratic would continue up and it would cross over top of the y-axis. And it's going to be somewhere way up here in the positives. Now, you could go through and do a bunch of work, or if you had it in standard form, the value of c is your y-intercept. So this is going to cross up here at 10, and we could just state from standard form, the y-intercept is 10. Don't forget to hit like, subscribe, ring that notification bell, and check us out next time when we're talking about quadratics in vertex form. Take care.